Hi, this is Rick for EDU Mobile. Now we're going to talk about view controllers. Finally, we're going to get into actual mobile app development with iOS. This is what you've been waiting for. I know we spent a lot of time on Swift, but you'll be thankful for that now that we're getting into it, that you don't have to learn things as you go. So here we go. View controllers. In iOS 8 apps, all iOS 8 apps that are running on mobile devices, there is at least one subclass of a class called UIViewController. Its function is to manage the display of views. View controllers are also responsible for processing events like button pushes and slider slides and anything else that occur on the views that they manage. And these are user events that I'm talking about. They also manage some other kinds of events, but view controllers basically are the actor behind the scenes for what the user is seeing on a particular display in an app. So we can think of a view controller like that. It's a very simple idea. Something has to control the view. So the architecture of this thing, usually we don't think about the entire architecture, but it's nice to know. First of all, we have the physical device screen, the display, the hardware, sitting at the lowest level of a hierarchy of things that display something on that hardware. So the next level is something called a UI window object. A UI window, the window it's called, abstracts that hardware into code and allows you, the developer, to present views to the user. All views that are added to the display somehow, and we'll talk about that in a minute, are subviews of the UI window. Now, a subview sits in an array or an array hierarchy of UI view things, views. UI window is itself a subclass of UI view, but it's a special subclass of UI view that knows how to interact with the device screen, the hardware. So kind of sitting between this UI window and the views is a UI view controller. And that view controller manages all of the UI Windows view stuff, the UI Windows view hierarchy. And it handles user events, as we already said, on the views. So let's look at the picture of this. Here, over here on the right, I have the screen. A UI window maintains a property called screen that refers to the device hardware screen. It also maintains a property called root view controller, which refers to the view controller that is, let's say, the main view controller. Now, different view controllers can be displayed, and we can switch them in and out in an app, and we do that, certainly, but there's always one root view controller, main view controller. Now, that view controller has a pointer, or bad word. That view controller has a property called view, and that is the main view for that view controller. Now, there's also a relationship between the window and that view, and it is the member of that window's array of subviews. Then that view has an array of subviews called subviews. That is all of the subviews, maybe controls, maybe other views that are inside that view, inside the view controller's view. So at this point I realize that I'm saying the word view a lot with different meanings, and it's a little bit difficult to understand what I'm saying. But this becomes really pretty simple when we realize that for the most part we don't have to concentrate on the device screen at all, because the window is an interface to the screen, and we really don't have to concentrate much on the UI window, because the view controller is kind of wrapping all of this stuff up for us. So the window interfaces with the screen. That is the background side of things. And then the view controller is what we deal with, and everything else is handled for us by the system itself. So again, even though the views are actually subviews of the window, we don't really have to worry about that, at least not for now. So let's talk about the view controller, because that's where our interaction and our development typically starts and ends, really. So the view controller maintains a property named view, and this view property is the background screen, quote screen, not the hardware screen, but the screen that the user sees for each view controller. So you might imagine that we might have several different view controllers, each one in an app displaying a different screen to the user. You might think that's the way it works, and that is in fact the way it works. So we can pop new view controllers on, we can push them off, we can do a lot of different things, and that essentially is what the first half of this course is about, is learning how to deal with view controllers and their views. So we've got this view property. Now any controls that we add to view, including subviews or other views, will be subviews. And I put this in square brackets because it is an array. But any of those controls that are added to view will be subviews of view. And just know that subviews, view.subviews, is an array of views. So what am I talking about here? Primarily I'm talking about controls. All user interface controls are either direct or eventual subclasses of UIView. When I talk about a view, I am talking about either UIView itself or subviews of UIView, or subclasses of UIView, I should say. Now, let's talk a little bit about what it means for a control to be active and passive. And these lines can be blurred a little bit. I like to think about active and passive not in terms of the control itself, but what the control is currently doing. So in my idea, controls that are responding to events are active controls, at least while they're responding to events. And controls whose display changes in response to code are what we call passive controls. So active controls, the user taps it or slides it or moves it or does something else with it, and something happens. And what happens, we'll talk about in the next slide. But passive controls either just sit there and display information, or they can only change. They don't do anything when they're tapped or interacted with, and they can only change in response to code. So that's kind of the distinction there between active and passive controls. And we will see as we go through the course that sometimes an active control, what we think of an active control as like a button or something, can be acting passively in terms of what we have to do with the code. So active controls, first of all. Active controls, the idea is pretty simple. When a user interacts with an active control and expects something to happen, an event is generated. And the view controller can choose to respond to events on controls by handling them in something called an IBAction method. What's an IBAction method? An action method is simply a regular method, a func, that is preceded by this @IBAction specifier. IBAction is a signal to the compiler that the method will be connected in some way, usually wired up in Interface Builder, to a particular event that happens on a control. So here we have a method, at least the header of a method, a function that is declared IBAction called buttonClicked, where we define a parameter sender as any object. This is the basic header. Concentrate for now on where IBAction goes. It goes before the declaration of the method. So passive controls, if a control changes visibly as a result of something that happens in code, then that control needs to be declared as a var property of the view controller. It has to be a var, it cannot be a let. Such a control is acting passively. The declaration for that control must be preceded by @IBOutlet. And again, @IBOutlet is a signal to the compiler that the property will be wired to control in Interface Builder. So this looks this way. We precede the declaration, IBOutlet, var, and then whatever the control is, named label, that's the property name, and then UI label. Notice that the type has a bang after it. Get into the habit of declaring your outlet variables, your outlet properties, as implicitly unwrapped optionals. At the beginning, you won't see the need for this. At the beginning, we're going to be wiring these things up, and of course that has a value. But later on, we can bind these properties, these outlet properties, to a control at runtime. So if it's not bound at compile time, it needs to be an optional. And it also needs to be implicitly unwrapped. It makes our life easier. So we know what an optional is. We've talked about Swift. So get into the habit of using an implicitly unwrapped optional on your type for outlet properties. Thank you very much.